Okay, this is the Unit 2 practice quiz. So we have a rectangle, and rectangle A measures 12 centimeters by 3 centimeters. Rectangle B is a scaled copy of rectangle A. So we already know that rectangle A and rectangle B are copies. Okay, so our 12 by 3 is the original measurement. Okay, so keep that in mind, that's our original measurement. We're going to select all of the measurement pairs that could be dimensions of rectangle B. So when it says select all, that means that it's a multiple choice question. Could be one answer, could be multiple correct answers. So what we want to remember, it's one of the first things we look through in lesson 1. When we have scaled copies or dilations, we've got ratios. And the ratio we're going to use to help us with this problem is we're going to compare the long sides of the rectangles to each other and the short sides. Okay, so long side versus long side, we're going to put that in a ratio and see if we can make it equal to the short side over the short side. So let's look at A. So the long side of rectangle A is 12 and the long side of option A is 6. The short side of rectangle A is 3 and the short side of option A is 1.5. What we're going to do is we're going to try to make equivalent fractions. I'm going to try to make the 3 over 1.5 become 12 over 6. So if you look, I was able to, using math, I have to have everything still correct. Using math, I was able to find an equivalent fraction that equaled 12 over 6 because that equals my original ratio. A is an answer. Okay, let's look at B. Long side of rectangle A is 12, long side of rectangle and option B is 10. The short side of my original rectangle is 3. The short side of option B is 2. Okay, so just in case, I want you to see where these numbers are coming from. So that's my original, my long side. The long side of option B is right there. Okay, so that's where I'm getting, I know it's the long side because 10 is bigger than 2. Okay. All right. So what I need to do, excuse me, is again, I'm going to try to make equivalent fractions. So 3 times 4 is going to equal 12, which gets me the same numerator. But remember, whatever I multiply on top, I have to multiply on the bottom. 2 times 4 is 8. 8 is not equivalent. 8 is not equivalent to 10. So my goal is to get 12 over 10. I could not get 12 over 10. So B is not an option. So for C, I'm going to compare long side to long side, see if I can make it equal short side to short side. Remember, my rectangle A is all on top, and the option for C is all on my denominator. Now to try to make equivalent fractions, I can make 3 times 4 become 12, so my numerators are equal. But if I multiply my denominator by 4, I do not get equal denominators. So C is not an option. D, same process. Ratio of long to long. See if I can make it equal short to short. Now again, I can multiply 3 times 4 and equal 12. But if I multiply 3 times 4, I have to multiply 4.5 times 4. I end up with 12 over 18, which is equivalent to my original fraction here. So D is an option. Same thing with E. And we're going to go through E quicker. So take a look at E again. We're making ratios, long to long. I want to see if it equals short to short. And I can make them equivalent, so E is also an option. So A, D, and E are my answers. You would have to get all three of those. Number 2, here are 2 polygons. Draw a scaled copy of polygon A with a scale factor of 3. So let's do that first. Now you might notice there is no center point given. Okay, we didn't give you the center point anywhere. That means you choose where the center point is at. Okay. This is where I chose my center point. You can see it right there in red. So with that center point, the first thing we're going to do before I can do anything else is I'm going to make rays that go through the 3 points or the vertices of that triangle. So those 3 vertices need rays going through each one. That's step 1 for using my scale factor. So a scale factor of 3 means I'm going to measure from my center to my first vertice. And then I'm going to take that measurement and I'm going to duplicate it 3 times. Okay, so starting from the center, 1, 2, 3. Those are my 3 scale factors. Back that up. So I take the distance 1 time, 2 times, 3 times. That gives me my new point for my scaled triangle. And I'm going to do it again for the next point. This is my measurement from my center to the first vertice, or the next vertice on A. Now you would be using an index card or a piece of paper to measure. So I'll take that measurement and I'm going to measure 3 times because my scale factor is 3. Once, twice, 3 times. That gives me the next vertice for my scaled triangle. Same thing with my last vertice. I'm going to measure from the center to the vertice. And now because my scale factor is 3, I'm going to triple the length. So I start over from the center, once, twice, 3 times. Now, if you notice, I went off of my line, and that's okay. I can still get my point. And now I have my new 3 points and my new triangle. One thing to notice, my scale factor was 3, which means my triangle should end up bigger than it was originally. It's actually 3 times bigger. Now for the next one, I wanted to zoom in for you because we have a scale factor of 1/4. Because the scale factor is 1/4, I know my final figure will be smaller. Actually, it will be 1/4 of the size. Pick a center anywhere you want. I just tossed a point down. And I'm going to draw my rays through each of the vertices of my figure. I'm going to measure to the first vertice that I want to choose, whichever one you want. And because the scale factor is 1/4, I actually need to break that distance up into fourths. So you'll notice here, I've got 4 equal sections. Now my scale factor is 1/4, so that means my point is going to be 1/4 of the way away from the center. I'm going to repeat the process on the next part. Measure to the vertice, cut it into fourths. 1/4 away from the center is my point. Again, measure the distance, break it into fourths, put my point 1/4 in. And finally, there's my last quarter. That's my 1 scale factor of 1/4. Now again, you could have your center anywhere. That's just where I picked mine. That's your final shape. Number 3. So for number 3, we're going to dilate some points on the circular grid. Okay, one thing, the center isn't given to you in this case because we're assumed that the center is right in the middle of that grid where you see the red point. Something to remember, one of the things we talked about when we looked at the circular grids was the distance from the center to the point times the scale factor is equal to the distance from the center to the new point. Okay, so remember that pattern while we're doing this. Okay, so for A, we're going to dilate point A using a scale factor of 2. So the first thing I want to do is measure from the center to A, and that's 3 units. It goes through 3 circles, right? Then I'm going to multiply that original distance times my scale factor. Okay, that's where my 2 numbers are coming from. It's going to equal 6. So that means the distance from the center to my new point is 6. So the distance from the center to my new point is 6. There's A prime. Point B. We have a scale factor of 3. So the first thing I'm going to do is measure the distance from the center to B. That's 1. I'm going to multiply by the scale factor. That equals 3. 3 is the distance from the center to my new point. Remember, we have old distance times the scale factor gives us our new distance. So the new B, B prime, is 3 away from the center. Last one is point C. Our scale factor is 1/2. And remember, if the scale factor is larger than 1, we're going to get bigger. If the scale factor is less than 1, we're going to get smaller or shorter. So the distance from my center to C is 8 units. Okay. 8 units times my scale factor of 1/2 equals 4. So that means the new distance from the center to C prime is 4. Because my scale factor is 1/2, it's going to be halfway away from the center that C was. Okay, number 4. Here are points A and B. Plot the points for each dilation applied. So A, dilate point B using A as the center and the scale factor of 3. Okay, so A is our center. So when I draw the ray, I start at my center and I go through the point that's going to be dilated. Scale factor of 3. Okay, so we're going to measure from A to B, and because we have a scale factor of 3, I'm going to take this distance and measure 3 times from the center. Okay, so here's 1, 2, 3. So original distance was 1 unit, scale factor is 3, so I'm going to triple it, and I end up with C prime. Remember, taking our original distance, multiplying it by 3. So 1, 2, 3. That gives us our point, C prime. B. We're going to dilate point A now. B is the center. Scale factor of 2. So draw your ray. And we're going to measure from A to B. Now, because it's a scale factor of 2, I'm going to double this distance. But I start at my center again. So starting at B, we're going to double the distance. Okay. So that's twice as far from the center. There's my D prime. Oops. I guess we could label it just D. C. Dilating point A again. B is still the center, and the scale factor is 2/3. So draw our ray. There's our distance, but we want a scale factor of 2/3. So I'm actually going to break my distance into thirds. And my scale factor of 2/3 means I'm going to measure 2/3 away from the center. That's 2/3. And there's my new point E. That's it. Number 5. Triangle ABC is dilated using D as the center, scale factor of 2. The image is A prime, B prime, C prime. Claire says the two triangles are congruent. Do you agree? Explain how you know. So do we agree if these two triangles are congruent? So let's remember what congruent means. Congruent figures have the same side lengths and angle measurements. They're exactly the same size, same angles, same everything. Carbon copies, perfect copies of each other. These are not that. One is smaller than the other one. If there's a scale factor of 2, that means something got double in size. So that means our side lengths are not going to be the same. So I do not agree. They are not congruent because the corresponding side lengths are not equal. We're not supposed to say not down there. Oops. Okay, so side lengths are not equal. There we go. Number 6. On graph paper, sketch the image of quadrilateral PQRS under the following dilations. Okay, so this is not multiple choice. This is 3 separate problems. So we're going to start with A. Dilation centered at R with a scale factor of 2. So because our center is R, we're going to draw our rays from R through the other vertices of our shape. Then what I want to do is you can use your measurement tool with like an index card or whatever, but we're going to look at this with a pattern. So I'm going to check out the pattern from R to Q, or the directions horizontally and vertically. My scale factor is 2, so I'm going to take that pattern twice from the center, and that gives me my Q prime. Then I'm going to look from R to P. So if I follow a horizontal and vertical directions from R to P, because it's a scale factor of 2, I'm going to do this twice. So I'm measuring the pattern 2 times. And that gives me P prime. For R to S, I'm going to find the directions from R to S, horizontal and vertical, over 2, up 2. My scale factor is 2, so I'm going to do that pattern twice. Remember, it's twice from the center. Okay, it's not twice after the first time. It's 2 times total. If you look at each of these sets of patterns, I took the measurement horizontal and vertical 2 times. That gives me my new points. Now the only thing we're missing, I have a Q prime, a P prime, an S prime, but I don't have an R prime. Okay, that's because my center is actually on my figure. So R prime is in the same place that R is. So that's your final shape for A. I'm going to bring that back in just a few minutes, but let's look at B. Oops. So for B, got a little ahead of myself there. The dilation is centered at O, and the scale factor is 1/2. Okay, so the first thing I did, if you look at the yellow lines, ignore that Q prime for a second. The yellow rays are going from O through each of the vertices. So O through Q, O through P, O through S, and O through R. Now my scale factor is 1/2. So I'm looking for half the distance from the center to the point. So halfway from O to Q is where I marked Q prime, if you see that there. Now I need to find half the distance from O to P. So I'm going from O to P, and it's over 2, and it's up 5. So I need to go halfway. So instead of over 2 and up 5, I'm going to go over 1 and up 2.5. Do not eyeball halfway. Okay, if you notice, when you go over 1 and up, you actually run right into the ray. So for S I go over 6, up 4. I need half of that. So I'm going to go over 3 and up 2. That's S prime. Now remember, we're going to the point. Okay, so that's why we're further up here. I'm not going to the line, the first line it hits. Remember, we're going to the vertice. That's why we're measuring here. And we're cutting that measurement in half. Okay, so for my next one, from O to R, for O to R, I go over 4, up 2. Halfway is over 2, up 1. When I connect my points, that's my new quadrilateral. Let's take a look at C. So for C, the dilation is centered at S with a scale factor of 1/2. So I'm going to travel from S to P. So from S to P, I go up 1 to the left 4. Halfway is going to be up 1/2 to the left 2. There's my halfway point. Now from S to Q, I go down 1 and I'm going to go backwards 6. So my halfway point is going to be down 1/2 to the left 3. For S to R, it's down 1 backward to the left 2. Down 2 to the left 2. So halfway is going to be down 1 to the left 1. Now, same thing happened that happened on A. We're missing S prime. S prime is actually, because it's the center, remember, if the center is on the figure, the center is part of the new dilation. That's the quadrilateral we get. And though that should be what your paper looks like, you'll have all 3 on at one time. Number 7. 7A. Draw the dilation of triangle ABC with the center of dilation 0, 0, scale factor of 2. So I've already marked the center in green on A. Our scale factor of 2. Now I'm not going to draw rays on this because I want you to just kind of see how to work the grid without the rays, in case that's helpful. If you need the rays, you can draw rays as long as you want. So I'm just going to focus just using the grid for the pattern. So let's see what happens here. I want to travel from my center to B. You could go to C first, or you could go to A first. Whatever order you want is okay. But I go down 2 to the left 2. Well, my scale factor is 2, so I need to double that pattern. And that gets me B prime. For C, I go up 2 to the left 2 from that center point. Scale factor is 2, so I double it. There's C prime. Finally, for A, I go down 2 to the right 4. I need to double it. And there's my new A prime. Connect my points, and there's my triangle. For B, my center is actually dilated point A. My scale factor is 1/2. So if I measure from A to B, it's to the left 6 units. I need half of that because my scale factor is 1/2. So B prime will be 3 units away. From A to C, I go up 4 and to the left 6. I need half of that because my scale factor is 1/2. So I end up going up 2 and to the left 3. That gives me C prime. Now remember, when our center of dilation is on the figure, our dilated point, I need to include that center point. So A becomes A prime. And there's my triangle. Remember, when the center is on the figure, you're going to get the visual where you've got like the 2 shapes sharing 2 sides like this. Or with a triangle, it'll share 2 sides. And finally, number 8 is review. Now, one thing I want you to notice, if you look at this, it does not look like I have parallel lines. Nothing in the instructions talk about parallel lines. They will tell you, they'll either tell you they're parallel, or you'll be able to see, because see how the measurement we're given on the left, the measurement here we're given on the left is 35. Excuse me, on the right here is 35, and this measurement is 27. If we had parallel lines, they would both be 35. So because these two are not congruent, that means we're not dealing with parallel lines. So keep that in mind as you're working here, okay? All right, so we'll take the angles on the left to start. These two angles together make a straight line, so they should add up to 180 degrees. That means that the angle to the left of 35 degrees is 145 degrees. Vertical angles are equal, so the angle across is also 145. Vertical angles are still equal in the opposite direction, so that means each of those are 35. Same type of situation on the right, except now we have 27 degrees that we're dealing with. These two should add up to 180. So my angle to the left is 153. Vertical angles, vertical angles. That's it. That should be the easiest one on here.